Here we go. Which correlation shows the causal relationship? Okay, the more minutes an asset is on playing field, the more goals it scores. That doesn't necessarily true. It doesn't work like that. The more gasoline that you purchase at the pump, the more you pay. I think this is it. The more, like let's say, the more you purchase, the more you pay. That's how it works. Although I would probably read the rest of the rest of the answer choices. The longer Sharpa stays at the bowl, the more purchases she makes, which is not necessarily true. Right? People can just walk in a shopping mall and not buy anything. So there's okay. So as the price of the gift increases, the size of the gift box increases. No, it can be very pricey thing with a really small box. So it's not necessarily true. So the correct answer is 2. It just proves it that it's 2. Moving on. Given f of x equals 3x minus 5, which statement is true? F of 0 equals 0. Is this true? So what we have to do when we have f of 0, we have to plug in the number that's inside of the parentheses into the function. So it's going to be 3 times 0 minus 5, which is negative 5. So no. When we plug in 3 here, we get 3 times 3 minus 5. 3 times 3 is 9, minus 5 is 4. And we have 4 here. It means that number 2 is the answer. Alright, at Benny's Cafe, a mixed green salad costs $5.75. Additional toppings can be added for $0.75 each. Which function could be used to determine the cost in dollars of the salad with as additional toppings? Alright, so we have the salad for $5.75 and the toppings for $0.75 each. So $5.75 we pay basically once, and then $0.75 we pay per topping. So again, 2. Oof, 2, 2, 2. All right. Which expression is equivalent to this quadratic function? For this, you just need to know your theory. You need to know what's called factoring. You need to know what's called factoring. So how do you factor that? We have to find two numbers that multiply to the last value, to the C value, and at the same time, the same two numbers must add up to B value. So what are these two numbers? These two numbers are negative 1 and positive 6. Why? 6 times negative 1 is negative 6. Checks. We have negative 6. And 6 plus negative 1 is positive 5. Check. So the correct answer will be plus 6 minus 1. All right, we're gonna move on to question number 5. So Peter has $100 to spend on drinks for his party. Bottles of lemonade cost $2 each, and the juice box costs 50 cents each. If X is the number of bottles of lemonade and Y is the number of juice boxes, which inequality models this situation? So on the left side, where it says 0, 50, X, and plus 2Y, first of all, we have to make sure that it's like X and Y is in the right spot. So lemonade is $2 and X is lemonade. So yes, 2, oh no, so 2 has to be with the X. So it means that 1 and 2 are wrong. Now, and juice boxes are 50 cents each, so they have to be with the y. All right, so now we have to choose between 3 and 4. On the left side, we have his spendings. His spendings must be less or equal to 100. It cannot be more than 100 because they only have 100 hours. All right, we're moving on. Number 6. Which domain is the most appropriate function that represents the number of items fx placed in the laundry basket each day x of the month of January? Okay, so laundry basket and the items in the laundry basket. So it's like clothes, basically, right? So for that, we need to know what these numbers all equal to. Let's say, so the first thing that we do is integers. Integers is whole numbers, positive and negative, so plus minus whole numbers. That's what they are. Now whole, like, okay, so whole, like, I didn't mean whole numbers in like a scientific way. I just meant that integers cannot be decimals, cannot be fractions. It's just whole numbers in that sense. Now the whole numbers are actually whole numbers that are only positive. That's what they are, only positive whole numbers. Rational numbers can be fractions or decimals. So it cannot, so basically laundry items cannot be fractions. We can't have 1/3 of a short or 1/5 of a jacket, right? So this is out of the question. And irrational numbers are here just for fun, because irrational numbers are like square root of 2 and pi. You know, basically it's impossible to have laundry items square root of 2. So the correct answer in this case would be whole numbers. The answer number 2. Why? Well, because we cannot have a negative amount of laundry items. It can only be positive. So that's why the answer is 2. It's pretty simple. All right, now a pure technicality question where we just have to solve this inequality. First thing that we have to do is to subtract 5 on both sides. Is going to be 3 over 2b less than 12. And now we have to multiply both sides by 2 over 3. Which is going to be b less than 24 over 3, which is 8. And that's it. B is less than 8. That's the answer. Moving on. Which table represents the exponential relationship? Exponential. Exponential means that the change in y should be not plus, but times. Like, let's say in the first answer is going to be plus 3. Plus 3. This is linear. Here it is plus 5, plus 5, plus 5. That's linear. Although number 3 is times 4, times 4, times 4. This is exponential. When we multiply, the increasing by multiplication is the exponential. Okay. Which expression is not equivalent to this? So what is that actually is if we simplify it? If we simplify it, it's going to be 5 to the power, and then we multiply powers. That's the power rule. We multiply these powers. So it's going to be 6x. So which one is not 5 to the power 6x? Number 1. This power times power, which is 5, 6 times x, 6x. So not this. Number 2 is going to be 5 to the power 3x times 2, which is 6x. Number 3 is going to be 5 to the power 5 times x, 5x. Oh, nope, that's not 6x. It means that this is the answer. Number 10. Which relation is a function? Now, number 1, is this a function? It's not a function. Why it's not a function? Because in this table, x values repeat. Here, 1, and here, 1. That means that it's not a function. X values cannot repeat. Number 2. Ooh, interesting. This is going to be hard to see, and I would put it off for a second because this is going to have to be graphed somehow. Actually, yeah, actually it's not going to be a function because in this case x less or equals to 2, and in this case it's x greater or equals to 2. Both of these terms are or equals to 2, so it can be 2. So 2 and 2, that means, but x's cannot repeat, so this is wrong. Now number 4 is 0, 2, 3, 3. 3 and 3 repeat. This is not a function. The correct answer is 3. Why? Because this function passes what's called vertical line test. It means that if we, no matter where we make a vertical line on this graph, it's not gonna cross this graph twice. So the answer is 3. Number 11. Number 11, I usually don't even read the first part because this is a classical question we have to solve for a variable. And we have to do y in terms of, that means we have to isolate the y. That's what it means, isolate the y. How do we isolate the y? So let's write it down first. It's going to be ax plus by equals c. How do we isolate the y? First, we get rid of the ax by subtracting it on both sides. We get by equals c minus ax. And now what we're going to do, we're going to divide everything separately by b, so that y will be left on its own. Or we can actually, so look at this, there is no separate fraction, so it means that everything was divided by b, which is also a possibility. So we cross out b here and b there, and we get y equals to this, c minus ax over b. That's the answer. All right, so we're moving on. Number 12. Number 12 is, what are the zeros of the function? Guys, for this question, I can show you how to do it graphically. And I think it's going to be the best way to do it. There's also a regular algebraic way, which is going to take a little longer. I can do it in class for all of you, but today I wanted to show you how to do it graphically. So what do? We put y equals on the graphing calculator, and then we do 2x minus 4, 3x plus 4. Okay, so 2x minus 4, 3x plus 4. And then we just look at where the x-intercepts are, which is at negative 1.333, which is usually negative 1 1/3, and 2. 2, 0, 2. So what is it? there's only two answers with 2. So this one doesn't have 2, this one doesn't have 2. So there's only one answer with 2. And I mean, two answers with 2, which is 1 and 4. But this has -4 and this has -1.333. This is going to be it. This is how easy it is if you know how to use graphing calculator on a question like that. You know, many years ago, I had a student who knew how to solve almost every single Algebra 1 Regents questions on his calculator. That was crazy. That was like the guy really mastered his calculator skills, which was pretty amazing to see. So questions like this, he just knew how to put in a calculator and get the answer. All right, and we're moving on. So Joe has dimes and nickels in his piggy bank, totaling 1.45. The number of nickels has 5 more than twice the number of dimes. So there's going to be dimes, and the nickels is 5 more than twice dimes. So it's going to be twice dimes plus 5. 5 more. 5 more is plus. Twice means 2 times. Which equation can be used to find? So it's going to be dimes with 0.10. Is going to be this 2d plus 5 with 0.05, because dime is 10 cents, and that's how 10 cents look like in a decimal. Nickel is 5 cents, and this is how 5 cents look like. And they all have to add up to 1.45. So the correct answer is 1. Dimes D, nickels times the representation equals 1.45. All right, number 14. Donna and Andrew compared their math final exam scores from the grade 8 to grade 12. Their test scores shown below. Which statement about their final exam scores is correct? So it's about mean, median, interquartile range, and third quartile for Donna's grade and the third quartile for Andrew. Wow. So we have to do quartiles. Interesting. In this case, it's actually not that hard because there's only 5 values there. So it's actually very doable. But in order to get the mean, what do we have to do? We have to add all of them and then divide by like 5. Same goes for the other ones. And you know what? This is also can be done on a calculator. You can just like write mean and put the numbers in, and it will actually give you the mean itself. What about the median? The median can also be determined by like the middle number. So how can you find it if they're not in order? You subtract the lowest, you subtract the largest. You subtract the lowest, you subtract the largest. And the one that's left is median, so it's 92. Subtract the smallest, subtract the largest. Subtract the smallest, subtract the largest. So 93. So no, their medians are not the same. Now, quartiles. And again, in order to calculate the quartiles, right, which is going to be like number 3, we have to put them in order. Put them in order, and actually, I guess let's do it. You know, I think there's no other choice. We do have to do it. Okay, so 87, 90. My mouse is not that good to write that small. Okay, so 90, 92, 94, 95. So the third quartile is going to be the number right before the maximum, 94. And what about, okay, so now let's do the next one, which is the other one. All right, so it's going to be 78. It's going to be 87. It's going to be 83. No, 93, 94, 96. So third quartile is going to be the same for both of them. Why? Because it's here. Minimum, min, Q1, median, Q3, maximum. That's how it works. The same goes for this, for the first one. So the interquartile range for, okay, so Andrew has the largest interquartile range. Andrew has 94 minus 87. That's what's interquartile range. Q3 minus Q1, which is 7. And 94 minus 90 for Donna's case, it's 4. So no. The third quartile for Donna is greater than the third quartile case. The third quartile for Donna is greater. No, not greater, is the same. So guys, I did this whole thing just to find out that Andrew has a higher mean. I don't even have to do it. It's just going to be the answer. Okay? Just by the process of elimination, we got there. Number 15. The first term in a sequence is 5. The first term is 17. What is the common difference? Okay. In this case, you can easily just work with your answers. Look at this. Well, like if we have term number 1, number 2, number 3, number 4, and number 5, right? And the first term is 5. And this is 17. Then just by adding, it will work. Like let's say it's not going to be 12, right? It's not going to be 12 because we have to add several times to get there, to get there, to get there, and then to get to 17. So I'm suspecting it's either 3 or 4. It may be 2.4, but let's see. 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. And 14 plus 3 is 17. So the answer is 3. 8, 11, 13, 14, and 17. Plus 3, plus 3, plus 3, plus 3, plus 3. That's the correct answer. All right. We're moving on. A quadratic function. Okay, a quadratic function and a linear function are graphed in the same set of axes, which is not possible. Okay, a quadratic and a linear function are in the same set of axes. Okay, the graphs do not intersect. That's possible. How is that possible? I want to show you how is that possible. If we have a parabola like this and we have a line like that, they will never meet, and so it is possible. The graph intersect at one point. That's also possible. How? If our line crosses the vertex and touches it only in one point. The graph intersects in 2 points. That's also possible. How? It's just a straight up going through the parabola, cutting through it. So it's going to be 2. But it cannot be 3. No matter how you try to make a line go through parabola 3 times, it won't be able to. That's why the answer is 4. The expression m minus 3 squared is equivalent to what? If you have a parentheses, if you have a parentheses squared, just clone it and do what's called foiling, which is first times the first over there, then first, then this, and then that. So it's going to be m squared, m times m, then m times -3, -3m, then -3 times m is -3m, and then -3 times -3 is +9. So the final answer will be m squared minus 6m, why? Because -3m and -3m makes -6m, plus 9. 3. 3 is the answer. Very technical. Nothing to think about, to be honest. Mrs. Rosanna asks her students to explain why 3 and -4 is a solution to this linear function. 3 students responded are given below. When equation is graphed on the calculator, the point can be found within this table. Substituting 3 for x and -4 for y into the equation makes it true. Okay, that's also legit, and this is legit. The graph of the line passed through the point 3, -4. Yes, that's also legit. That's all of them. This is all perfectly, not perfectly. Those are okay explanations why. I'm sorry. In this case, they're all working. All right. 4 quadratic functions are shown. Which statement is true? So for this, you're gonna need a graphing calculator, and trust me, guys, when you're gonna put all of them in a graphing calculator, the answer will. I don't even want to do this question. The answer will reveal itself to you, and except maybe the first one, but the maximum of the first one is 5. It's like written, so it's right here, right in front of you. Number 20. An example of 6-degree polynomial with the leading coefficient of 7 and a constant term of 4. The leading coefficient of 7. All right. So leading coefficient. So the biggest power has to be with a 7. So the biggest power here with a 6. No. The biggest power is 4 here with a 7. That's a possibility. And the biggest power of x to the 6 with 7 is also a possibility. And the constant term, you need to guys remember what is a constant term. Constant term is the term without variable. Just a regular number. And here it is. Just a 4 hanging in there. Okay. All right, guys. Today I prepared for you only 20 questions. It's going to be like a shorter version of today's class, which we're going to have next time with more students and in the same format when I'm going to just solve questions for you. I would like to probably have like more interaction during the class. I hope I'll be able to have such. But generally, this is how it's gonna look like, and I hope I'll be able to be more dynamic. And if you have any questions, I definitely would want you to ask them. But for now, this is going to be it for today, and I'll see you guys during your regular classes. So everyone, good night.